Okay, so let's take a look at this Leetcode trapping rainwater problem. It has some certain heights like 0 at the first, then 1, then again 0, then 2, and it is then 1, then 0, and things like that. So it is asking us that how can we trap this rainwater, and like can we calculate this rainwater and how can we trap it. So the very first thing that I saw in this question is like if you have a left and if you have a right, then the water would be trapped in between, right? It won't be trapped like here or here. So that's the very first thing. The second thing is like whenever water is trapped, it has a left and right wall. So there should be a left wall, there should be a right wall, and the water has to be trapped in between. The third and the most important thing is like if water is trapped between a left and right wall, then it would have the uh, height which is like the minimum of the left and right. So it would be trapped with the min of the right or the min of the left, like whatever is the minimum would get the water being trapped. So we know that how much water could be trapped in this because we can uh, see that let's take an example. If this is my left, this is my right, then I know, at least I know that if water is trapped and if I'm guaranteed that water is trapped between those two, then it will have this height. So with these things clear, we will just approach with the 2 pointer, and the way we will do it is like we will make a left which is 0, we will make a right which is like max, and we will make a left max, like what is my left max, which for now we can just say 0. We will make a right max which is also 0 for that, and we will just have water which we will keep adding in case, and that's the logic, that if the left exists and if the right exists, we will first proceed in, we will just go with the 2 pointer and just start processing the one which is smaller of the two. The reason why we process the smaller of the two is because let's just say that this is like just 1 and this is like 1000 here, and there is like nothing in between. Then also the water that will be trapped will be decided by the smaller one, not with the larger one. We would know that the larger one can trap any amount, like infinite amount of water, but if the smaller one just says that I have just 1 unit, then the water that will be trapped will be like the difference of the indices and multiplied by just 1 unit, because that's the smaller one that dictates the factor. So we will first decide that yeah, which one is like the smaller height, and we will just proceed with the smaller of the two height. Then we would just see that if this is the smaller, we will just start with this, and we will ask that if I am going towards the next one, is the next left that I'm proceeding to is smaller. If it is, then collect water. If it is smaller, collect water, because you are not worried about the right side. The right side is bigger than you, so you can just collect water. But if the newer left, let's say in this one, is like taller than the previous one, then just update the left max, because now this is your new left, and this is now based on which you can just calculate the water trapment. So this is the logic how we can just take care of the individual blocks that occur in between without updating the left max at every point. We just update the left max when it is like more taller than the previous one, and then based on that we just see that if we want to trap water, if we can trap water or not. So the question goes like, we have initialized all the left and right, we make a while loop. Let's say that while left is like not equal to right, like it is less than right, and we will increment the left and decrement the right. We will ask that if the left is smaller than the right, and if the left is smaller and the right is larger, we are not worried about the water trapment from this side, so we will just proceed with this one. We will ask that if the height left is like now greater than the left max, whichever the left max was, and let's say for the first time the left max is 0, so the height left is like greater, so just update the left max, don't do anything else, just update the left max, and left would get incremented as we are moving. If it is like not smaller, if the new left max is like if we cannot make the new left max because the water is like less, so because the height is like less, then we will trap the water, because we know that this is the space where water can be trapped, because the height is less, and we know that this is a bound which is like the smaller of the two, this can definitely contain the water. So the water would be left max minus height of the height of the I, which is whichever is the ith element, and then we'll just proceed with left plus plus. So one of the two things will happen if we are moving and the smaller wall, whichever the smaller wall is getting processed. Either the newer element would be smaller or larger. If it is smaller, just trap the water. If not smaller, then if it is larger or equal to, then just update the left max. Similarly, if it happened that let's say we are on this wall, and let's say that the right one is now greater or equal to, let's just say, because this is like processing if which one is like smaller. So let's just say that this one was smaller and we are on the right side, then we will just say that is the height of right, the newer height of right, whatever we are coming to, is greater than the right max. Like let's just say that if this was the right max for the moment because we went ahead with this one, and now we are asking is this greater than the right max. It is not, because this is like the greater wall, then water can be trapped, then we will just trap right max minus height of right and water will be trapped. If it is, let's just say for this example, when we have the higher height, then we will just say that update the right max. So we are just going from left and right, we are just checking whichever is the smaller wall, whichever is the smaller wall, we are processing it, and then we are saying, yeah, we are not worried about the right wall, it is like much taller, it will contain the water. Then just let me know that if the height that I am currently on is greater than the left max. Let's just say that this was the left max and we have proceeded to here, and now the height is like lesser than the left max, but it has some height. So we say that we can trap water here, there is no problem. From the right side we can just trap water, and we'll calculate by minusing the, we will just subtract the, deduct the height of left, and we will just deduct it and from the max height, and we get the water that is trapped, because it is like multiplied by 1 every time, it is like 1 unit. So we are getting the water trap as long as we are approaching to smaller and smaller, which is like smaller than left max. But whenever we approach something which is like more taller, then we know now we have more chances to get much water getting trapped. So we will just update the left max, and we cannot trap water because the height is now more. We cannot use that block to trap the water. So this is how we will move. And whenever we get a new left max, as we know that we are again and again moving between left and right, we would keep on comparing that whichever is the smaller one, we will just keep on going with that. So a right max and left max dictate that how the water would be trapped, and a left and right are just keep on moving, and they just keep moving. And to understand, like just keep trapping water, we are calculating water, and any one of the cases will always occur. Either the left wall would be smaller, or it could be that the right wall is smaller or equal to, and whenever that's the case, we will just process with the later one. Then the next thing could be that the newer height that we are on is greater than the max of the height, like right max or left max, or equal to, then we will just update the left max or right max. Or it could be like it is smaller, then we will just update our water, and we will just keep incrementing the left and keep decrementing the right till we have reached the conclusion where left is like no more smaller than right. So this is how this algorithm works. And yeah, if we just look at the code, first we have a left which is 0, which we have a right which is like right last index, which is like the height dot size, the size minus 1, the last index of it. We have a left max which is 0, the right max which is 0. In the very first case, we have the left less than right, we ask it the left less than right, and usually the case here would be that the left is like not the left is like less than right, because this is 0, this is height dot max. Then we will inside we will ask that if the height of left is like less than height of right, so the height of left and height of right it's actually equal to, so this is like not less than, so it will go to the next one, the else one. And then we will ask that the height of right is like greater than the right max, which is like yes it is, so the right max will get updated, and we will just move on the right with a minus minus. And now we will just again check like does the height of left, which is like smaller than the height of right, so yes, this is smaller than the height of right, the height of right is like now much bigger. So we will just see that if the height of left, whichever is the height of left, is like greater than the left max, so is the new height like greater than the left max is 0, so left max will get updated and nothing else will happen, and we will just keep moving on. The next time we approach, the smaller one would be still this, and we will just ask that height is like less than height of right, so this is 0, so the height is like definitely less. We will ask that is your height greater than your own your height is less than the right wall, but is your height greater than your own individual left max? It is smaller, so if it is like not greater, then we cannot update the left max, but we can trap water. So the water trapment will be left max minus height of left minus 0, so this water would get trapped, and the left would get plus plus, so we will just increment our left. This is how we will keep proceeding, and one of the 4 cases will always happen. Either the left wall will get incremented to a greater max and the left will get proceeded, or the right max would be the one getting the higher right max and the newer bigger wall, and it will get proceeded to a minus minus. or it could be that the newer is not like the maximum and some water can be trapped, so we'll just calculate that water trapment by subtracting with the height of left. Or it could be that the right is like not the big enough to be the right max, so we will just trap the water by subtracting the height of right, and we just keep our right max at it. So it is like 2 pointer, but it is like also like 4 pointers, because we keep a value of the right max and left max, and we just keep on moving. The approach or the while loop ends when the left is like no longer smaller than right. So if it is like equal to or the left is like greater than, so then we will just stop our loop. So yeah, this is a very nice one, because we always move or process the one which is smaller, so that we are not worried about the larger one. It can always trap water. The smaller one is the one that dictates our water, and we always check that if you are greater than left max, there is like no chance to store water, because yeah, like you are taller. So like from here to here, there is like no chance to trap water here, because you are like taller. We can just update our left max and or right max, and then later care about trapping water when a smaller one comes in picture. And whenever smaller one comes in picture, like if we are, let's just say that we are here, then also we do not proceed directly, because we always proceed with the smaller one, which is why this block does not have water storage, because we always proceed with the smaller one. So the way that we can reach this one is only from here. So these are some of the logic which are like aha moments for us, like process with the smaller one, increase the height, or trap the water. Process with the smaller one on the right side too, if it is that's the smaller one. Check if the newer height is greater than the right max. If it is, update the height or trap the water, and just keep on proceeding and moving. So the movement is decided by left and right. The motion of left plus plus right plus plus is always happening. One of them is always happening, and this is like this will keep going. The process of water storage is happening by whichever is the smaller wall, and if water would be stored or if the max would be updated is being decided if the newer height is like taller to update the left max or right max, or it is like shorter to trap the water in between those crevices. So yeah, this is the approach for trapping rainwater. I hope that was understandable, and that's the code in Kotlin. So yeah, see ya.